This is a video from section 3.11. We're going to start off by looking at the definition of the hyperbolic functions. Number 1 says the hyperbolic sine of x is equal to e to the x minus e to the negative x divided by 2. Number 2, hyperbolic cosine of x is equal to e to the x plus e to the negative x divided by 2. Number 3, hyperbolic tangent x is equal to the hyperbolic sine of x divided by the hyperbolic cosine of x. Number 4, the hyperbolic cosecant of x is equal to 1 divided by the hyperbolic sine of x. Okay. Number 5, hyperbolic secant of x is equal to 1 divided by hyperbolic cosine of x. And number 6, the hyperbolic cotangent of x is equal to 1 over the hyperbolic tangent of x. And with that in mind, we're going to look at some hyperbolic identities. And we're going to verify it. Okay? Now, let's start off with number 1. Here's the claim that cosh, or hyperbolic cosine squared x minus hyperbolic sine of x squared, right, is equal to 1. Okay? Now, let's start off with the left side. So hyperbolic cosine squared x minus hyperbolic sine squared x. Now, if we go back, hyperbolic cosine of x is e to the x plus e to the negative x divided by 2. And hyperbolic sine of x is e to the x minus e to the negative x divided by 2. So in other words, I'm going to rewrite both of these terms in terms of their exponentials. And so this is e to the x plus e to the negative x divided by 2 quantity squared minus e to the x minus e to the negative x divided by 2 quantity squared. Now, let's keep going. So I'm going to square the numerator and square the denominator. 2 squared is 4. And if I square the numerator, I'm going to get e to the 2x plus 2 plus e to the negative 2x minus, I'm going to put a 4 on the bottom, and I'm going to square the numerator. And so I get e to the 2x. Instead of a plus, it's minus 2 plus e to the negative 2x. And so this is equal to e to the 2x plus 2 plus e to the negative 2x minus, and in parentheses, you're subtracting the whole entire thing. So you get e to the 2x minus 2 plus e to the negative 2x. And we're going to take that and divide by 4. But if you notice, I'll use red here. Notice how the e to the 2x's cancel. Remember, the minus is being distributed to e every single term. And the e to the negative 2x's cancel. And so, therefore, cosh squared x. By the way, when I say cosh squared x, that's another way of saying hyperbolic cosine squared x minus hyperbolic sine squared x. This is equal to 2 minus negative 2 divided by 4, which is 4 over 4, which is equal to 1. And so what that says is hyperbolic cosine squared x minus hyperbolic sine squared x, okay, this is equal to 1. That's the first hyperbolic trigonometric identity. Now, let's start here. So the claim is 1 minus hyperbolic tangent squared x is the same as hyperbolic secant squared x. Well, we already know that hyperbolic cosine squared x minus hyperbolic sine squared x is equal to 1. So what we're going to do is we're going to divide both sides by hyperbolic cosine squared x. And when I do, I get hyperbolic cosine squared x divided by hyperbolic cosine squared x minus hyperbolic sine squared x divided by hyperbolic cosine squared x is equal to 1 divided by hyperbolic cosine squared x. But this is 1 minus, now in parentheses I get hyperbolic sine x over hyperbolic cosine x quantity squared, and this is equal to 1 over hyperbolic cosine x quantity squared. But what this says is 1 minus hyperbolic tangent x squared is the same as hyperbolic secant x quantity squared. Or we can write it this way. 1 minus hyperbolic tangent squared x is the same as hyperbolic secant squared x. And we're done. And let's take a look at one more. So, claim. Hyperbolic cotangent squared x minus 1 is the same as hyperbolic cosecant squared x. Now, we're going to go back here. We know hyperbolic cosine squared x minus hyperbolic sine squared x is equal to 1. Divide both sides by hyperbolic sine squared x. And so when I do, I get hyperbolic cosine squared x divided by hyperbolic sine squared x minus hyperbolic sine squared x divided by hyperbolic sine squared x. And this is equal to 1 over hyperbolic sine squared x. Now, this is equal to hyperbolic cosine x over hyperbolic sine x quantity squared minus 1. That's on the left side. On the right side, we get 1 over hyperbolic sine x squared. And we're basically done, because hyperbolic cotangent x squared minus 1 is the same as hyperbolic cosecant x squared. And therefore, we have our next identity. Hyperbolic cotangent squared x minus 1 is the same as hyperbolic cosecant squared x. Okay, so far we've proven 3 identities. Now, I'm going to show you another one. Claim hyperbolic sine of x plus y is the same as hyperbolic sine x, hyperbolic cosine y, plus hyperbolic cosine x, hyperbolic sine y. Now, the right side looks harder, and so that's where I'm going to start. I'm going to look at hyperbolic sine x, hyperbolic cosine y, plus hyperbolic cosine x times hyperbolic sine y. And then what I'm going to do is I'm going to rewrite each of these in terms of their exponentials. And so this is e to the x minus e to the negative x divided by 2. And I'm going to multiply by e to the y plus e to the negative y divided by 2. Plus. And then I'm going to take e to the x plus e to the negative x divided by 2 times e to the y minus e to the negative y divided by 2. Next line. So I'm going to put a 4 on the bottom, okay? Now, e to the x times e to the y is e to the x plus y. E to the x times e to the negative y is e to the x minus y. And then I get minus e to the negative x plus y. And then I get minus e to the negative x minus y. Okay. And then I'm going to put 4 on the bottom. And again, I'm going to get another e to the x plus y right here, minus e to the, this is e to the x minus y. So it's minus e to the x minus y, plus e to the negative x plus y. And then I'm going to subtract e to the negative x minus y. So it's minus e to the negative x minus y. I hope you guys can see that okay. Now we're adding, okay? So it turns out, and we have the same denominator, by the way, so this all is good. And so if you look at the e to the x minus y and the e to the x minus y, you get e to the x minus y minus e to the x minus y. Well, that cancels. And if you notice, negative e to the negative x plus y plus e to the negative x plus y, well, that's 0, right? And so what we end up getting is the following. So this is equal to 2e to the x plus y minus 2e to the negative x minus y divided by 4. So I'm going to factor out that 2. And I'm going to get e to the x plus y minus e. Now, out of that exponent, I'm going to factor out a negative that I'm circling. Okay, so it's e to the negative x plus y. And this is divided by 4. But 2 goes into 4 2 times, right? And so what this is e to the x plus y minus e to the negative of x plus y divided by 2. And so this is indeed hyperbolic sine of x plus y. And after all that work, we can now say that hyperbolic sine of x plus y is the same as hyperbolic sine of x times hyperbolic cosine of y plus hyperbolic sine of y, hyperbolic cosine x. Now, claim hyperbolic sine of 2x is equal to 2 times hyperbolic sine of x hyperbolic cosine of x. So now, here's what we know. We know hyperbolic sine of x plus y is the same as hyperbolic sine of x times hyperbolic cosine y plus hyperbolic sine of y hyperbolic cosine of x, of course, multiplied together. Now, what I'm going to do is I'm going to let x equal y. And so hyperbolic sine of 2x is the same as hyperbolic sine x, right, times hyperbolic cosine x plus hyperbolic sine of x times hyperbolic cosine x. And this is 2 times hyperbolic sine x hyperbolic cosine x. And so you guys notice where I get the 2x, I just take x plus x and I get 2x. And so therefore, hyperbolic sine of 2x is the same as 2 times hyperbolic sine x hyperbolic cosine x. And so that's a double angle identity. Let's address a couple of more here. Claim hyperbolic sine of negative x is the same as negative hyperbolic sine of x. So this shows that the hyperbolic sine is an odd function, by the way. Okay. Now, start with hyperbolic sine of negative x. Well, this is equal to e to the negative x minus e to the opposite of negative x divided by 2. And so this is e to the negative x minus e to the x divided by 2. Now, if we're okay, I'm going to factor out a negative. So hyperbolic sine of negative x is e to the negative x minus e to the x divided by 2. And I'm going to take out that negative, and I'm going to get e to the x minus e to the negative x divided by 2. But we should recognize this now as the hyperbolic sine of x. So I could say that this is negative hyperbolic sine of x. And so therefore, hyperbolic sine of negative x is the same as negative hyperbolic sine of x. Okay. Claim we'll do this one. Cos x, in other words, hyperbolic cosine x plus hyperbolic sine of x is equal to e to the x. So start with the left side. It looks harder. So I'm going to take hyperbolic cosine x plus hyperbolic sine of x. So this is e to the x plus e to the negative x divided by 2 plus e to the x minus e to the negative x divided by 2. Now, add them up. So we get e to the x plus e to the negative x plus e to the x minus e to the negative x. This quantity is going to be divided by 2 because we have the same denominator. The e to the negative x's cancel, and we get 2e to the x divided by 2, but the 2's cancel, and we get e to the x. And so what we can say is that hyperbolic cosine x plus hyperbolic sine x is the same as e to the x. So let's do one more for this video. Yeah, we're going to do one more. Claim. If we take hyperbolic tangent of natural log of x, so this is going to be the same as x squared minus 1 over x squared plus 1. Now, start with the left side. Hyperbolic tangent of ln x is hyperbolic sine of ln x divided by hyperbolic cosine of ln x. So that's a fact, right? So we at least have that to start with. Now, I'm going to start here. So we have hyperbolic sine of ln of x divided by hyperbolic cosine of ln x. So this is equal to e to the ln x minus e to the negative ln x divided by 2 divided by e to the ln x plus e to the negative ln x, right? And we're going to divide that by 2. 2's cancel. And so we get e to the ln x minus. Now, I'm going to get rid of that negative exponent, if you don't mind. So I'm going to say minus 1 over e to the ln x divided by e to the ln x plus 1 over e to the ln x. But remember that e to the ln x is nothing more than x. And so, therefore, hyperbolic sine of ln x divided by hyperbolic cosine of ln x, well, this is going to be the same as x minus 1 over x divided by x plus 1 over x. And what I'm going to do is I'm going to multiply numerator and denominator by x. And when I do, I get the following. I get x times x, which is x squared. X times 1 over x is 1. And then I divide by x squared plus 1. And so, therefore, we can finally say that the hyperbolic tangent of ln x is the same as x squared minus 1 divided by x squared plus 1. And that is a good stopping point for this video. This is section 3.11, and we went over hyperbolic identities. Okay, thank you.